formed a neutronium ion. And a neutronium ion is comprised of one nitrogen and two oxygens, and both of these oxygens are double bonded to the nitrogen, which means that the nitrogen will have a positive charge. This also means that nitrogen cannot form any more bonds because it has 4. So for this neutronium ion to attach itself to the benzene ring, it will have to lose one of the bonds that shares with the oxygens, which will create this. And this group will be able to join with the benzene ring. The benzene ring will have to lose a double bond because there is a hydrogen here still.
When the double bond within the benzene ring breaks, it takes the electrons with it, giving the other carbon it was attached to a positive charge. This is the Lewis structure we got when we attached the nitronium ion to the benzene ring and got the positive charge on this carbon. Because Lewis structures show fixed electrons, we have resonance structures to show the delocalization and movement of those electrons within the molecule. Here are the resonance structures. So we have this one, and then this bond will move and bond here, putting the positive charge on this carbon. And then that bond will move there, putting the positive charge on that carbon.
So as you recall from earlier, we have a sulfuric acid missing a hydrogen with a negative charge on one of the oxygens.
To balance out the charge of the benzene ring attached to the nitronium ion, this will be used as a base. It will attach to this hydrogen and take it off, putting the electrons back to the carbon. So this balances out and becomes our sulfuric acid again. And that allows the double bond to go back into the benzene ring, taking away this positive charge with the electrons, while our ion is still attached, creating our nitrobenzene.
So nitrobenzene, the nitro group is a meta-director, which will mean that either here or there will a new group attach to. So since we are reacting with Cl2, we have the hydrogen here, and in order for it to bond here, it needs to detach from the bond. So one of the Cl's and the Cl2 come in, attach to it, and create HCl, and then goes alley-oop, and so then we get Cl bonded to meta,
which can also look like this.
What happens when we try to react nitrobenzene in a Friedel-Crafts alkylation? Well, here you see we have an alkyl group, and it would ideally react with AlCl. However, because nitro is a strongly deactivating group, the Friedel-Crafts alkylation will not undergo. So this will not attach to the benzene ring, and a reaction will not take place.
With our nitrobenzene, we can do a reduction reaction to turn each individual bond on the oxygens, so in this case 3, because there is one double bond O and one single bond O, into a hydrogen using zinc and hydrochloric acid as a catalyst, which then would make the NO2 turn into an NO3 on the ring, giving it a positive charge. The reason why it is not turned into NH2 is again because of it's the individual bonds to the oxygen, not how many oxygens there are.
He's bald and he's hurting people who have hair.